In today's video, we're overclocking the AMD Ryzen 9 5900 B2 processor all the way up to 5152 MHz by Shaminocharging Precision Boost Overdrive using the Crosshair 8 Extreme motherboard. Please note that this is for entertainment purposes only, so it's definitely not the whole picture. Please don't outright copy the settings you see in this video and apply them to your system. If you want to learn how to overclock this kind of a system, please have a look at the more lengthy SkatterBencher video. Alright, let's do this. When you've entered the BIOS, go to the Extreme Tweaker menu. Set AI Overclock Tuner to DOCP Standard. This will make the memory run at our XMP rated DDR4 4266. Set BCLK frequency to 104. This will increase our precision boost algorithm frequencies by about 4%. So, if the algorithm sets 5000 MHz, then the actual frequency will be 5200 MHz. Set memory frequency to DDR4 4229 MHz. Because we increased the BCLK frequency by 4%, our XMP rated frequency also increased by 4% to DDR4 4437. Since this is a bit too high, we set a lower memory frequency. Set Core Performance Boost to Enabled. This will ensure Precision Boost Overdrive is enabled while using a manual BCLK frequency. Enter the Precision Boost Overdrive submenu. Here's where we'll do most of the grunt work by tuning Precision Boost Overdrive. Set Precision Boost Overdrive to manual. Set PPT limit to 205, TDC limit to 150, and EDC limit to 195. This increases the power, thermal, and current headroom of our motherboard VRM. Set Precision Boost Overdrive Scaler to manual and 10x. This tricks the PBO algorithm into thinking our CPU is much better than it actually is, so it will push for higher voltages. Enter the Curve Optimizer submenu and set Curve Optimizer to per core. Here's where the real magic happens, as Curve Optimizer allows us to adjust the VF curve for each core by up to 30 steps of 3 to 5 mV. Setting a negative curve means the CPU will use less voltage for a given frequency. That in turn results in lower power, thermal, and current. This in turn gives more headroom for setting higher voltage, and that gives us higher frequencies. I tested each core individually to find out what's the best Curve Optimizer setting. Set Core 0 to Core 11 Optimizer sign to negative. Set Core 0 to Core 11, except Core 2, Curve Optimizer magnitude to 30. Set Core 2 Curve Optimizer magnitude to 25. Leave the Curve Optimizer submenu. Set Max CPU Boost Clock Override to 200 MHz. This increases the frequency ceiling by 200 MHz over the programmed max 1T boost limit. On the 5900, that's 4750 MHz, even though the listed maximum boost frequency is 4700 MHz. Adding 200 MHz results in a ceiling of 4950 MHz. Leave the Precision Boost Overdrive submenu. Enter the External Digital Plus Power Control submenu. Set Core Voltage Suspension to Enabled. Voltage suspension will force the CPU core voltage to stay within a specific range even when using a dynamic voltage like with Precision Boost Overdrive. Set CO Mitigator to 0.3. This helps mitigate system instability when using aggressive Curve Optimizer settings by boosting the voltage ever so slightly under very light loads. Set Voltage Floor Mode to Dynamic. Dynamic mode allows us to configure a custom voltage temperature curve. This will make the target voltage range change based on the operating temperature. The voltage floor is the lower bound for the target voltage. Set floor low Vmin to 1.15. Set floor hot temp to 90. Set floor high Vmin to 1.40. Set floor cold temp to 60. Set voltage ceiling mode to dynamic. The voltage ceiling is the upper bound for the target voltage. Set ceiling low Vmax to 1.20. Set ceiling hot temp to 85. Set ceiling high Vmax to 1.53125. Set ceiling cold temp to 65. Voltage suspension is effective up to 0.3 volt delta between the requested voltage and the target voltage. So, at a temperature of 65 degrees Celsius, the voltage ceiling is 1.53 volt. If the CPU requests 1.6 volt, then the voltage will be 1.53 volt, as the difference between both values is less than 0.3 volt and the ceiling is 1.53 volt. Leave the External Digi Plus Power Control submenu. Enter the Tweaker's Paradise submenu. Set Force OC Mode Disable to Enabled. This will ensure manual OC mode is disabled while using a manual BCLK frequency. Leave the Tweaker's Paradise submenu. Set CPU core voltage to offset mode. Set offset mode sign to plus. Set CPU core voltage offset to 0.075. Go to the advanced menu. Enter the AMD CBS submenu. Enter the CPU Common Options submenu. Set Global C-State Control to enabled. This will ensure proper frequency scaling when the BCLK frequency is over 101 MHz. Then save and exit the BIOS. To make sure everything is working as intended, we rerun some benchmarks and check the performance increase compared to the default settings. Higher is better and all our scores are higher. When running Prime 95 small FFTs with AVX disabled, the average effective CPU clock is 4455 MHz with 1.23 volts. The average CPU temperature is 84 degrees Celsius and the average VRM temperature is 51 degrees Celsius. The average CPU package power is 197 watts. The highest core clock reported in the operating system is 5152 MHz. This is much higher than our adjusted frequency ceiling of 4950 MHz. When using the core cycler application to check the effective clock frequency in a single-threaded workload, we find that the average peak effective clock in single-threaded applications across all cores is 4866 MHz. And that's it. Thanks for watching and till the next time.